suddenly what we're finding is that with neural networks and with deep and wide neural networks specifically, and the different types of neural networks that we're able to compose and put together, that it's actually just about more data. So more data creates a better prediction than a better or more finely tuned or handcrafted model.
Welcome back, guys, and it's great to see your lovely faces. Today I'm interviewing Christoph Wertz, who is one of the most tenured practicing engineer in the AI, ML, and data science space. You've seen those job postings where they require 20 plus years of experience in machine learning. Well, our friend over here has that. He's been crunching data since the year 2000. In the past, he's worked with companies like Amazon, as well as for a long time at Cloudera, which is a parent company of Hadoop, if you're familiar with that. And now he's working at Google Cloud as a customer engineer, helping other enterprises leverage and gain insights from their data. Well, today he's with us to drop massive value bombs. He'll tell us what is ML and AI and how the space has evolved in the past 20 years. He will give us some practical examples of how companies are leveraging machine learning and artificial intelligence today. And if you're a software engineer right now at a company, he'll tell us how your company can start leveraging your data and gain insights from it. And lastly, if you're a professional trying to break into the AI/ML space, or if you're just starting out, he'll tell you exactly what you need to do today to up-level your skills. So here we go. Hey, Christoph, thank you so much for joining us. Really excited to hear about your journey in the past 2 decades on the big data and AI and machine learning, helping a lot of customers out there. So just to get started, Christoph, just tell me a bit about yourself and how did you get to your current profession right now with Google Cloud?
Sure, thanks, and thanks for having me. So it's been kind of a long journey, a couple of decades, 20 years, literally from the year 2000 to the year 2020. Kind of goes in the blink of an eye. It's interesting because I'm still doing big data analytics and MLAI, and it's actually kind of what I was doing 20 years ago. So, one of the first startups I ever worked at was a company called Athene Software, and they were in Boulder, Colorado. They were a little software startup during the .com boom. So went there in January of 2000, and we were doing churn prediction for wireless companies and for ISPs. And so at the time, the U.S. was still in like growth mode. And acquisition mode, but the rest of the world was a little bit more advanced than the US was. And so we had customers in like South America and in Europe. And so, we were dealing with terabyte sized data sets back in 2000. And, that was big data. Back then that was big data. And we were actually doing churn prediction, and we were using neural nets to do churn prediction. And that was 20 years ago. We actually had Jeffrey Hinton, Andrew Moore, who is either a VP or SVP at Google now, and Mike Mosier, who's a professor at University of Colorado at Boulder in machine learning. They were either on our board or on our advisory committee. I don't remember exactly which one. But at the time, it was big data, and we were using neural networks and machine learning to predict churn, and the tools have changed drastically in the last 20 years, obviously, and the size of the data sets too.
That's amazing. And Christoph, when we think about big data, there are a lot of different connotations. In your experience, when someone says big data today, what does that mean?
It's kind of funny because I've actually gone from talking about big data to just calling it data. And this has been part of the interesting journey because there's been this whole move to big data that started probably 10, 15 years ago with the GFS and MapReduce paper and this concept of data locality, right? And so we had to go from scale up to scale out because the data sets were starting to get big enough that we just didn't have the ability to hold the entire data set on a single machine. So scaling up or making a single machine bigger just wasn't working anymore. So we had to scale out to distributed systems. And so the GFS and MapReduce paper comes out, and then obviously the open source community picks that up and creates HDFS and MapReduce, and it's kind of like Hadoop is born, right? And so, but the cloud wasn't here yet. And so people that were dealing with large amounts of data were starting to build out, big data on-prem. And so, they built out the infrastructure to try to support, terabyte data sets and then petabyte data sets. But we've kind of gotten to the point now where we've migrated to the cloud and we have the hyperscale cloud providers, and then with object storage, whether it's S3, ADLS, or Google Cloud Storage, you could support petabyte or exabyte size data sets with replication, with durability, all of those things. So, we've gone from this journey 20 years ago to where we were trying to scale everything up to, 10 to 15 years ago, and then probably, 5 years prior to now to 10 years prior to that, just that segment of the whole big data ecosystem with variety, velocity, and volume. And that was kind of what people meant by big data, right? Variety, velocity, and volume. Like high speed, a lot of it, and it may be structured, it may be unstructured, right? And so, now there's just all these tools to just store enormous data sets of any variety, whether it's structured or unstructured, and then all of the tools to build these end-to-end pipelines. And so it's definitely been a big journey from over the last 2 decades, I would say.
The thing with data is that by itself it's useless, right? Unless you can gain meaningful insights out of it, it doesn't really mean much. So let's kind of bring it to reality. Let's say you have a company, big company like Coca-Cola or any other company that you have experience with. How would collecting and making sense of that data would help them, and what kinds of insights would they be able to extract out of it?
No, sure. I mean, absolutely. I mean, the data doesn't exist in a vacuum, right? There's a reason for the data, and there's a reason why big data became important. And the reason for having data is to gain insights, right? And so whether you look at a business trying to know where the business is at and trying to do forecasting or where the business is going, at the end of the day, you're collecting all of this data about the business so that the business understands what happened. And so they need to know what sales were, where they were, what the regions were, what products are doing well, what products aren't doing well, what the issues are, how to address them, how to be flexible, how to adapt, right? How to compete, all of those things. And the whole reason for having the data is to be able to ask and answer those questions. You go from relational, RDBMSs to, OLAP, right? OLAP was all about trying to build up analytical systems on top of businesses to help them understand where their business had been. And so, big data is just about gathering more data about the business so you can ask these questions and more importantly, answer these questions. But even there, where that's going, it's going from, hey, what did the business do? Right? Like what happened? What happened last quarter? What happened last half? What happened last year? To what's happening now? Right? Like, can I get near real-time information streaming systems? And you think of things like in the open source community, you've got things like Kafka, different publish subscribe type mechanisms, ActiveMQ, RabbitMQ, like all of these messaging and queuing systems to try to tie systems together in real time. Google has PubSub, which is managed in serverless. And so the whole point is to try to get closer and closer to the current time. So you go from wondering what happened to my business to what's happening to my business right now. But then you start bringing in machine learning and AI, and the whole point is what's going to happen, right? So now it's about, can we predict the future? Can we predict where our business is going to go so that we can adapt to it? And big data is deeply intertwined with artificial intelligence, and artificial intelligence, machine learning, artificial intelligence has gone through a series of, booms and busts, or, there's been lots of research, and then there's been an AI winter because it's been overhyped and underdelivered. And so I think we've been through 2 AI winters to this point. But then suddenly what we're finding is that with neural networks and with deep and wide neural networks specifically, and the different types of neural networks that we're able to compose and put together, that it's actually just about more data. So more data creates a better prediction than a better or more finely tuned or handcrafted model. And so once we've kind of come to that understanding, then the whole point is to gather as much data as possible. So the more data you have, the better the models are, and you're actually better off having more data with maybe a less optimal model than trying to handcraft or fine tune a model with less data. And so that's the drive for big data, and it's all about driving and predicting where the business is going or where the future is. Speaking about specific companies that I've worked at, I haven't worked at Coca-Cola, but you could certainly talk about what kind of data they would have, right? They're selling however many different types of products, whether it's regular Coke, whether it's Diet Coke, whether it's caffeine-free Diet Coke, whether it's their, Coke regular sugar product. And they're selling all of these different products. They have them at different locations in the store. They might be on a stock shelf. They might be on an end cap. There might be a promotion running. They may be in a vending machine, right? They may be they may be at McDonald's, right? And it may be on tap, right? So like every single instance of any piece of their product is a piece of data. And capturing all of that data and understanding what's happening with their business, what's happening with their product, what are people buying, where are they buying it, why are they buying it, and then not only that, honestly, like carbonated traditional soda fountain type drinks are actually kind of on the out a little bit. And so not only do they need to understand their product and their market and how their products are selling in their market, they need to understand the competition too. And so they need to understand energy drinks and vitamin waters and all these other things that people are buying. And so those are enormous data sets, and it's a multi-billion-dollar industry, right? And so to gather all of that data and be able to do the analytics on it and do the machine learning on it and do predictive forecasting on it and understand where to drive the business and how to move forward and how to grow, those are incredibly challenging problems. And that's what people are using these data sets for. And the bigger the data sets get, the better the tools they need to operate on those data sets. And we're finally getting to a point where we have amazing tools, right? And that's why I say, like, I've kind of gotten to where I say big data is dead. It's not about big data anymore because, you can put exabyte scale data sets in cloud storage and operate on those and scale out. And so, we have petabit fabrics in our data centers. And so we've gone away from data locality, where we had to co-locate the code with the data because of the algorithms for processing that data, to separation of storage and compute, because now we have petabit interconnect fabrics between storage and compute. And so it's no longer data locality like it was with GFS and MapReduce and Hadoop 10, 15 years ago. The current thinking and the current offerings are managed in serverless, and it's all about separation of storage and compute. And so that's kind of the thinking, like the big picture understanding of what big data, why big data, what companies are using it for, and even kind of like the more recent shift in a way away from being constrained by the on-prem solutions for what's termed to be big data.
Let's get into the weeds a little bit. Obviously, you've been in space for a long time, and you've seen not just the space, but also the tools themselves evolve over time, right? Back in the days, like you mentioned, a couple of decades ago, most of it was happening on premises. Yep. And folks needed to buy bigger instances and scale out and buy a lot of hardware if they want to churn or process a lot of data. On the other hand, now it's all in the cloud. That also means that you gain a lot of pre-made, SaaS-like tools to make sense of your data. So how have you seen the space evolve? And after that, also interested in where do you think the space is going?
No, absolutely. Yeah, we've definitely seen the space evolve. I mean, we've seen the space evolve as even, the companies that are using the previous tools have evolved. In terms of like the evolution and then where it's going next, I always go back to the original like GFS MapReduce paper as kind of like the inception for like big data and Hadoop, right? And so, if you think of that first paper, but then you think of the fact that essentially HDFS or GFS is an immutable object store. Obviously that's not useful if you need to update things, right? So that it becomes very difficult to update things. So, the next step is to get to where you have, a data store that is mutable. So you've got Bigtable, and then out of Bigtable and those NoSQL solutions, came things like HBase and Cassandra and MongoDB and all of the solutions around key value stores and NoSQL. And so it went from having kind of a large distributed immutable object store to, having more of an online, NoSQL store with low latency where you could actually modify the data. And then the evolution from there has really kind of moved towards like these cloud object stores and buckets and those sorts of things. And so We've really seen that kind of come into the picture. And then the different real-time processing pipelines that enable the new real-time pipelines like Kafka, obviously, for on-prem. But I think, a lot of it has to do with companies wanting to avoid vendor lock-in too. And so there's been a really big focus on open source. And so companies, everybody went through, most enterprises and companies learned the lessons of like the 80s and the 90s, right? Like they bought from Microsoft, they bought from Oracle, they've dealt with vendor lock-in. And now we have Linux, which is an open source operating system. A lot of the big data tools that companies are using on-prem are open source tools. And Google even has invested heavily in the open source ecosystem. And if you think of TensorFlow, like, Google's helped, establish that and drive that out into the marketplace and open sourced it for people to use. Dataflow is based on Apache Beam, which is an open source solution. So you have enterprise companies that want these big data solutions and they need them for the reasons that we've already talked about, but they're also trying to avoid vendor lock-in. But what's happened is that there's this shift to where it's just much more efficient for companies to run in the cloud because they just can't manage and operate a data center at the scale and efficiency that the large hyperscale cloud providers can offer. And so, Google's secret sauce, partially is the hardware, right? It's the network, right? It's we have machines that we build and petabit networks and the data centers that we build and our network so that the majority of our traffic actually runs over Google's fiber network. And it's that physical infrastructure that even enables things like Spanner, right? If you think about Spanner and you think about like the CAP theorem, like Spanner is essentially consistent and available, and that's getting way down into the weeds, obviously. But what enables a solution like Spanner, which is both consistent and available, is the fact that we have the hardware and the network that Google does, and that's what enables a solution like Spanner. And so,
and for context, Spanner is our distributed SQL
yeah, if
SQL
you think of like
database.
OLTP versus like OLAP, right? So if you think of like operational versus analytical, so for operational or RDBMS SQL based, normalized, you would use Google Spanner for that. If you're thinking about in that like row based storage, those sorts of things. If you're thinking about analytics, columnar, that sort of storage, and that's what like BigQuery would be used for. And so, and so that's the difference between the two systems. Just think of like operational versus analytic, or OLTP versus like columnar and OLAP, right? But again, it's really the hardware and the quality and kind of the SRE or site reliability engineering that's gone into that hardware, that data center, that network, that everyday companies like Coca-Cola, like that's not Coca-Cola's core competency, right? Coca-Cola's core competency is not building out data centers or infrastructure. And so by asking them to deploy these solutions on-prem, my experience from being at Cloudera and being a senior solution architect is that the systems are just too complex, right? Like, even companies that were somewhat tech companies, I would see them just like struggling under the weight and the complexity of these big data systems that they're trying to use, because there's so much management that goes into implementing that infrastructure, and then upgrades and, machine upgrades and everything that goes with that. And then just a lack of knowledge around that. And so there's so much friction to implementing those big data open source solutions on-prem that, frankly, I think that's why we've seen the cloud take off, right? Because it's just so much easier, right? Like, if I can go use a managed serverless solution, on the one hand, you've got the business that's somewhat concerned about vendor lock-in, but on the other hand, they're getting answers, right? They can put terabytes or petabytes of data into the system. They can run SQL queries, and they can get their answers out. And they don't have to think about networks. They don't have to think about data centers. They don't have to think about any infrastructure. They don't have to think about hardware. And so when you ask me, like, where do I think it's going, and okay, thought experiment. Let's think that perhaps it's going back on-prem, right? Like let's just think like maybe that's the future. Maybe the future is that Coca-Cola is going to get into the business of building out like their own servers, their own racks, their own petabit networking, their own global infrastructure, right? Like I just don't see that happening. I don't see that happening. And more and more, those things are becoming commoditized, right? Like Coca-Cola may have a backup generator, but they probably, for the most part, don't generate their own electricity, right? They use a utility provider. Now they may use two utility providers, but they don't. They typically don't generate their own electricity on a regular basis because it's just not efficient, right? Like they probably don't have well, they might have their own water refining plant because it's Coca-Cola, but most businesses probably don't have their own water refinery, right? And so I think, I mean, everybody's heard this before. This isn't new. Like the whole, utility, like the whole concept of computing as a utility isn't a new concept.
Right. If someone else can do it cheaper and they can get a better service out of it, then why not?
Absolutely. And again, the why not is that the enterprise is concerned about security and they're concerned about lock-in, right? And that's where Google has really tried to embrace the open source ecosystem, and we're focused on open source like Anthos, Apache Beam. Those are open source projects that we contribute to and we support. And so, yes, if you want to run Apache Beam, we've got Dataflow. It's managed serverless, and it's going to, our focus is on making sure that we have the hardware that you can run that in the most efficient manner possible. But it is Apache Beam. If you want to run it on Spark, if you want to run it on Flink, and you want to take it somewhere else, then you can do that. And I think that Google specifically has had a major focus on making sure that there is the option to be hybrid, multi-cloud, and that we help vendors address the concerns that they have for their solutions.
Makes sense. And it's also a cycle, right? Where the cloud facilitates the gaining insights from data very easily. And that helps companies do more of it. And then that kind of, pushes the cloud to do it even more. And then that's how we have seen the explosion of data engineering and data science jobs kind of explode, right, in the past 5, 6 years.
They're able to focus on just the data science part of it, right? They're not, companies can now spend that money on their core competencies and on value add. They don't have to spend that money necessarily on the same level of networking that they used to spend it on, or the same level of infrastructure that they used to spend it on. I mean, even just think about the internet, right? Like, go back 20 years, go back 30 years, trying to build out networks between companies was probably a very difficult thing, and today, a company can just, set up their internet connection and they're on the internet, and, they just take networking for granted as a service. And so, compute's just going to be something that people use, and whatever computing language you're using for the problem you're trying to solve, whether it's Beam for like streaming processing workflows, or whether it's SQL for structured data and analytics, which isn't going. I don't see. So you talk about the future. SQL's not going anywhere, right? Like SQL is going to be around for a very long time, and obviously higher level languages and those sorts of things. But it's just not. It's going to continue to keep being commoditized, and there's not going to be any value add or benefit for most companies to focus their energy and their money. If you think of the resources that they have available, whether it's time, people, or money, right? Those are the three things they have: time, people, and money. And the cloud just lets people move faster with less people and spend their money somewhere else.
And also, I think when we talk about data lakes, then SQL isn't the right tool anyways, right? Because in something like an HDFS, which is Hadoop's data store, you can have any kind of document like PDFs and XML files and any other kind of document, and then together you kind of gain insights from it. Isn't that true?
I would actually say that's a bit of a misnomer. I mean, people like to think that because of the fact that big data or Hadoop supports unstructured data. But the reality is that, most engagements, and probably 99% of what people did with big data solutions, is just put Hive on top of it, which is SQL, right? So they really were just using them as, you think of like in terms of like data lakes, it really wasn't about the variety of data or unstructured data, because most of the data that companies have is structured data. I mean, they're used to working with databases, and so Hive on Tez, Impala, Dremel, BigQuery, like all of these are like SQL structured data solutions. And so the key value of data lakes is really breaking down the data silos. Again, you scale up, but you can't scale out. And so with the big data solutions, you now have the ability to scale out, right? You could actually bring all of your different data sets into the same tool, and you can run analytics across everything, right? Like, you don't have to have your data siloed for a particular product or region or for whatever reason. Maybe you're bringing in weather data, maybe you're bringing in solar data. I mean, whether or not it's relevant. And now all of a sudden you have access to all of these different data sets and all of your company data from everywhere in the world. And that's where you're able to drive these new insights that previously just weren't possible.
I remember up till at least like a couple years ago, big data was synonymous to Hadoop.
Yeah.
Right? Is that the case right now?
I think it was synonymous to Hadoop because if you wanted to implement big data, it was just too expensive in the cloud at the time. And between cost and security, I just don't think the enterprise was really ready to go to the cloud with their data to begin with. And the cost of storing terabytes in some of these companies up to petabytes of data and trying to do that in the cloud was just prohibitive. And so as they migrate to the cloud and they migrate their application to the cloud, they also have to think about being cloud native. This is something that I talk about, I have to talk about with my customers right now. Yes, Hadoop was synonymous with big data. So when people think about taking their big data to the cloud, if they think about lift and shift, then they look at it and like it's just too expensive. And the reason it's too expensive is because they're looking at virtual machines with attached disk. And if you're trying to build out clusters in that configuration and have terabytes or petabytes of data storage on HDFS, it's cost prohibitive, right? And so they need to start thinking about like object stores in the cloud, like using Google Cloud Storage, which is much more affordable. And even BigQuery storage is the same about the same cost structure as Google Cloud Storage. And so you can put all of your structured data into BigQuery storage. You can process it with SQL. You can process it with Dataproc. You can process it with Spark. And at the same time, you can put your unstructured data, like if you have images or audio or video or those sorts of things, you can put those in cloud storage. And that allows you to have a data lake that has all of your data and put the unstructured data into cloud storage and put the structured data into something like BigQuery. But yes, they used to be, that was synonymous with big data, which is why there was so much hype and excitement about it, over the last 10 years. It's certainly, why, I went to Stanford and got a graduate certificate in mining massive data sets. And that's why I ended up at Cloudera in 2015 and worked there for almost 5 years. Right. And, but we saw the ground shift and you could just see that as the cloud, the cost equation for the cloud and security got better, that's just where the market was going, and there's no turning back.
What kinds of pushbacks do you get right now? Do you still get customers and companies kind of hesitant to use the cloud to make sense of data, or has the conversation kind of shifted to only making sure that I'm choosing the right vendor and I'm choosing the right tools on the cloud?
I would say it's about 50-50. I would say half the time I still get pushback about migrating to the cloud. And a lot of that has to do with just the nature, I think, of our profession, right? If you're a software engineer, you want to engineer things, right? And so, part of your reason for existence is because you want to build something, you want to engineer something. And when all of a sudden some of that complexity is taken away from you, you may have to retool a little bit, right? So, I was actually part of the team that rewrote zapposcouture.com and 6pm.com after the Amazon acquisition. So the year and a half prior to going to Cloudera, I was working at Amazon on rewriting all of zappos.com. And so, the back end of that was all microservices, right? It was all service based. I basically wrote, all of my account for Zappos.com, and I'm, was deeply, deeply intimate with the payment instrument API at AWS, right? And so, you're not dealing with databases anymore. And so then the question becomes, what do all the DBAs at Zappos do? Where do they go? Right? And that's a difficult question, right? And if you're a DBA, it's a very relevant question. And so this is, I think, some of the struggle and pushback that we get from the industry as a whole, is that, this probably won't be very popular for me to say, but there are entrenched interests for engineers to continue to engineer things versus using things that provide a solution for them, right? Why not use a system where you can just load your data and query it? I mean, at the end of the day, you want to run a SQL query on your data, right? So if cost isn't an issue, if it's not about cost, and you can just put your data somewhere and you can run a query against it and get the answer that you want or that you need in the time that you need for a cost that you can afford, why would you ever build out another database, SQL-based cluster system, whatever, when that's available to you? And so there is a level of control and a level of entrenched interest that engineers have in, not wanting to migrate away from those systems. And then there's also the business risk of people wanting to avoid vendor lock-in. And I kind of push back on people a little bit when I have those conversations, because, yes, there's going to be some challenges if you're porting from one SQL system to another. I mean, if you're going from a Teradata to an Atiza to Hadoop to BigQuery to whatever, right? Like there's obviously some pain in migrating from one solution to another solution. But at the end of the day, it's your data and it's SQL, and you're going to be able to take it somewhere else if you have to. So starting to see more understanding, more adoption of that. I think what's really driving it is the business need to accelerate, and businesses understanding that, like, their competitors are doing this, right? If their competitors not spending their money on managing their infrastructure, they're spending it on accelerating. They have flexibility. They can respond to customer demand. They're spending it on accelerating. And so if you have this constant drag of this on-prem infrastructure that you're committed to being tied to, then your customers are going to win and you're going to lose over the long term.
And eventually, you might get pushback today or this year, but eventually it's going to happen, right? So I think it boils down to changing skill sets and kind of adopting in terms of professionals. And we see it in a lot of different industries, right? I think even in software engineering, a lot of the jobs that were there with the antiquated skills no longer exist right now.
Yeah, well, and I think our job is learning, right? Like, that is our job. It's not that our job is to be like a Fortran programmer, and I'm going to be a Fortran programmer for life, or my job is to be a DBA and I'm going to be a DBA for life, right? My job literally is to learn. That is my job. And so, I've gone back to school many times and starting classes again this fall, and I'll probably keep taking classes as long as I'm working. And, that is our job, to continually keep learning. And, whatever platforms are available today, those are going to evolve too. And the more flexible they are, the more rapidly they might be able to evolve. And, we do need some stability, because, you can't change everything out from underneath people like all the time. You can't have that much churn. But it's going to continue to evolve. And, 5 or 10 years from now, things are going to look different from what they do today. And our job is to keep learning. That is our job.
Especially in the profession that you're in, right? And in order for you to advise customers on a daily basis, you have to make sure that you're up to date with everything that's going on in the field. And that's not easy.
Yeah, absolutely. Yeah, it's challenging to keep up, for sure.
So now lastly, Christoph, I'm interested kind of bridging, the 2 points where we know now what big data is, what the tools are, your experience with some of the customers in helping them kind of gain insights from their data through the cloud technologies. But today, let's say there's a company out there that wants to gain insights from their data, right? Maybe they have a small data set, they're not really doing anything from it. Maybe they are collecting data right now with the hopes of eventually, someday, kind of gaining insights and monetizing that data set. What advice do you give them?
My advice is really use the right architecture, right? Like make sure you start off with the right architecture and keep your costs down, right? And use an architecture that you know can scale. I mean, in a way, you're insuring against the future, right? Um, if you have the right architecture and you use the right components, and just for instance, if you can at least afford to use Spanner, PubSub, Dataflow, and BigQuery, like right there, you have your OLTP solution that's essentially infinitely scalable. You have a real-time streaming solution that is global and distributed. You have the kind of the T and the ELT solution for transformations and different things that you need to do with Dataflow, and then you have your analytical solution on the back end with BigQuery, and obviously getting into like machine learning and AI platform and all of those other things. But just by starting off with that basic architecture, and not that those components are cheap for a small company, but if you can at least try to keep your costs down and start off with those components, they're going to scale with the company. Like they're going to flex up as quickly as the company needs to flex up. And in a situation like what we're dealing with right now with the global pandemic and COVID-19, and they're going to scale down as well. If you've invested in on-prem infrastructure, that doesn't scale down when your business needs to scale down. And so they really need to focus on big picture, right components, use things like Google Cloud Storage and use BigQuery for analytics, and look at things like Spanner for your OLTP or operational systems. And if you can focus on the right components for the architecture, that architecture will scale the way that it needs to as your business does. That I think is, if I'm starting my own business today and I'm a startup and I'm picking the architecture and components that I need, those are the components that I'm picking, and I'm making that case to my investors, and that's how I would run my business. And find a good partner. Find a good partner. When I say find a good partner, find a cloud provider that actually cares about your success.
And essentially, my understanding is that you start with creating the pipeline, and you're referring to the architecture of the pipeline itself. Once you have that, you have the data set up in the right way so that you can start gaining insights from it.
Correct. Yeah, the first step is to collect the data, right? If more data creates better models, then the first step is just capture more data. Absolutely. And it's also important to iterate more quickly. And that's where I kind of mentioned ML ops earlier in the conversation. And that's kind of taking the DevOps CI/CD mentality and applying it to machine learning. And we're starting to see some evolution along those lines with Kubeflow pipelines and TensorFlow extended. And so, part of the conversation that I'm having with my customers right now is really around ML ops and how do they do, continuous integration, continuous testing, continuous deployment with machine learning models, not just with their application serving. And so, start collecting the data, but pick the right tools and set up an automated pipeline, right? And then spin the flywheel, right? And do it fast. And that's an important part, is to pick the right tools and then to be able to run through those tools in an automated, integrated fashion and do that quickly.
And lastly, Christoph, you've been in space for a long time, right? You've evolved your skill set, but we also have a lot of professionals that are now kind of entering the space, or kind of, have entered the space, but trying to evolve their skill sets to make themselves more valuable. So what would be your recommendation if someone wants to evolve their skill set right now?
My recommendation is to definitely focus on the analytics skill sets. Focus more like on the analytics, the data science aspects of the job, because if the compute part of it just becomes automated and it's just a cloud offering, there's not going to be a lot of value in being able to tie together, if all you know how to do is tie together like pub sub and data flow, like there's not a lot of value there, right? So if the value is in the data, growing your ability to understand that data and transform that data or govern that data and how that's important to the business and drive insights from that data, and that's specifically like data science. I've heard someone say that a data scientist is either someone with a computer science degree that has a little bit of statistics, or someone who's a statistician that has a little bit of computer science. And so, data science is kind of like this intersection of like computer science and statistics. And so, I would say if you're super heavy on the computer science, take some statistics classes. And if you're a statistician and super heavy on the statistics, take some computer science classes. And I would just keep going in that direction, because it's going to be about the data analytics, and then the machine learning and those sorts of things that are going to provide value to the business. It's not going to be about the infrastructure. It's not going to be about virtual machines and networking, and in terms of where I would give people advice of where to focus their career on today. It's where I'm spending my time. So
Yep.
so,
Makes sense. And to that point, it's also important for them to work for an employer that is doing cutting edge things.
Absolutely. Yeah, absolutely. And I think it's got to be difficult for an employer to recruit and retain talent when they're not adopting these sorts of things, because if you don't have a relevant current skill set, then you're not valuable in the marketplace. And so, if you're focused on technology, like if you haven't even looked at Kubernetes, you don't even know what a container is. I don't know how an employer attracts top engineering talent if they're not doing those things, right? So it's important as an employee to work at an employer that's doing that. It's also important for an employer to know that they need to be focusing on those technologies to also attract and retain top talent. So it kind of goes both ways.
Makes sense. All right, Christoph, this was a really good conversation. Thank you for your time.
Thanks, Irfan. Lots of fun. Thank you for having me.